when we're doing inequalities, our solution is actually going to be the graph. So remember, like, graphing and shading things?
Oh, you figure that out.
Okay.
I'm really bad at this.
We will work on it. I think you'll get it. So, how do you know when you graph them if you're using a solid or a dashed line?
The sign, the alligator.
Yes. If it has an equal to, then you would need a solid. If it does not have an equal to, it would be a dashed line. Okay, if I want to graph this line, what would I need to do first? Actually even easier than that.
Just cover up one of the way.
You could do like cover up method to get a couple points, or this is just a line. What if we move it to y equals mx plus b form? So if I subtract over my x, then that's a line. Y-intercept is 2, so you would put a dot at 2. Slope is -1, so down 1 over 1. And then, was this one solid or dashed, did we decide? Solid. Equal to is solid. Let's see, I can't draw very straight lines, so just pretend. Yeah, I was just going to ask, are any of you perfectionists? Would anybody like a ruler? Huh?
What was the part of our homework?
Yes.
I was going to put it here sometime.
Okay. Then, with the inequality, we have to decide where to shade. So you probably decided that by picking test points. Usually you use 0, 0. That works as long as it's not on the line itself. Any point not on your line would be fine. If you tried 0, 0 and you plugged it in here, you would get 0 is less than or equal to 2. Is that true or false? True. So 0, 0 works. We're trying to shade one side of this line. We want to shade the side that works. So 0, 0 worked. So we're shading everything down here. This isn't our final answer yet, so just kind of lightly shade that part in. All right, so let's do the second one the same way. So we need to get y by itself. So if we graph it, we have a y-intercept of 4, slope of -2, so down 2 over 1. Solid or dashed? Solid, because it doesn't have, or because it has the equal to, excuse me. Okay. And then we need to decide where to shade. So we could do 0, 0. You get 0 is greater than or equal to 4. Is that true or false? False. So 0, 0 did not work, so that means you have to shade the opposite side of the line. Now what's my actual answer? Right, that area where they're both shaded. So in between these two lines right here is my answer. That means any ordered pair I picked in that region makes both equations true. You need to make sure that I can tell what your final answer is. So that area needs to be darkened in, or some people like to take a highlighter and highlight that part, or some people go back and erase their other shading. I don't care how, but somehow that needs to stand out from the rest of the graph. That is the actual solution. Questions there? Let's try them. Right, so if I were going to graph this first one, we need to get y by itself. So I could subtract my x. And then I would have to divide by -2, which does what to my inequality? Which just flips it. Be y is greater than -1 over -2 is positive 1/2 x. 6 divided by -2 is -3. So we have a point at -3, slope 1/2, so up 1 over 2. Solid or dashed?
Dash.
So for the shading, you can continue to pick test points, and a lot of people like to do that. I always try to point out as well, this says y is greater than. If it's greater than, you're going to shade above your line, less than shades below your line. So if you see that and you know, oh, that's greater than, I'm going to shade above, that's fine. You don't have to show me that you put in a test point. If you don't recognize those, you're welcome to go ahead and do that test point. You get 0 is greater than -3, and that's true. So again, we shade the side 0, 0 is, which is above the line. So we're shading everything up here. What?
My whole life's been a lie. We always had to put 0 there.
Alright. So next one. So if I subtracted over my 2x, divide by -4, which flips my inequality. So I get y is less than 1/2 x. So how do you graph that? Y-intercept is 0, slope is 1/2. So up 1 over 2. Did not have an equal to, so that's another dashed line. Could you use 0, 0 for a test point this time? No, because it's on the line. So you would have to pick something not on your line, or if you use the trick I just gave you, this was less than. So where should we be shading? The bottom, below the line. So what's my overlap this time? Everything between the 2 lines. Now we're not only going to do this with lines, we're going to do it with several other different kinds of graphs. I could give you any inequalities I wanted. So let's say I gave you this one, x squared plus y squared is greater than 9. Does anyone know what x squared plus y squared equals 9 would look like? What would that graph be?
It would be just, slope is 1, but at 3.
But it's not a line, is it?
A circle.
It is a circle. We haven't really talked about circles. What do we do when we don't know how to graph something?
Type in.
We can use our calculator. We will have to solve for y before we can put it in our calculator. We can pick points, right? So if you didn't know, like somebody mentioned cover-up method earlier. If I covered up my y, if y is 0, what would x be? So when y is 0, you would have x squared equals 9. So what's x? 3. So that really gave me 2 points. When my y is 0, x could be 3 or -3. What if I put in 0 for my x? Then I get y squared equals 9, so y is positive or -3. So I could have the point 0, 3, and 0, -3. Does that kind of show you what your graph's going to look like? Yeah. This will be dashed because it didn't have an equal to. out where to shade. Not as obvious here as when we did lines, so let's try a test point. If we tried 0, 0. You get 0 is greater than 9. True or false? So 0, 0 did not work. So where am I shading? Everything outside this circle. Okay. Let's graph this. So we would get y is less than or equal to negative x plus 3. So that would be a line. Y-intercept is 3. Slope is negative 1, so down 1 over 1. That would be a solid. Can you tell where that one's going to shade? Down. It would shade everything below because of the less than, or you could do a test point. So the overlap here is under the line but outside the circle. So something like that. Do you guys remember doing this stuff? Is it going okay so far? I have several examples left. I want to do at least 2 of them. We can do more if needed. I'll put some photographs at the end if we need extra practice. I want to try at least 2 more. What's this first graph? Parabola. We should know that one. We've seen that. What does the -4 do to my parabola? Yeah. Or if you needed to, you could put in points. So we have 0, -4, 1, -3. If x is 2, get 0. Just my normal parabola shifted down 4. It would have to be a dashed because we didn't have an equal to. Do you know where you would shade on this one? Inside. If you weren't sure, try 0, 0. You get 0 is greater than -4, which is true. So 0, 0 works, so the inside of my parabola is true. Second one is just a line. Y-intercept -2. Slope is 1. Solid because of the equal to. Which side of this line do we shade? Less than is below. So what's the overlap? This little part inside our circle here. The last 2 examples I have are more of the same, but they just have more than 2 equations because I could have as many equations as I wanted in here. And the idea is the same. We're still just looking for the overlap with all those equations. I think I want to jump to this one because that first inequality is a little bit different than some of the others that we've seen. I want to make sure you know how to handle that. All right. What do you think it means when you see something like this?
In between.
Yes. X equals is a vertical line. right? So if you have it in between two values, it's essentially saying we have two vertical lines and we're shading in between. They don't have equal tos, so both of these would be dashed lines. So we have a dashed line at -4. Dashed line at 0. And we're just shading in between. Okay, next one. We can subtract our x. So our y-intercept is 2. Slope is -1. Dashed line. Where is that one gonna shade? Up, yeah. So far, it's just this little section between the lines of, between those pink lines and above my black one. I also have one more equation. So this would be y is less than -2x plus 10. So if we start at 10, slope is -2, so down to over 1. And that would also be a dash. Where is that one shading? Below. So kind of hard to tell, it went off our graph just a little bit here, but our overlap is the area above this black line in between the two pink ones. And as this blue line continues, it's cutting off the top. So basically as that blue line extends, if you keep going a little ways on your paper, it's going to cut it off there. And that would be our stopping. All right, so we can have multiple lines. Same idea. Any issues? Then I think I'm done. I want you guys to work on the first 4